Alright, so I'm going to talk briefly about extending what we've done already, figuring out the maximum number of mistakes, extending that to the non-separable case. And basically this is exactly the same as with just a single perceptron. What we're going to do is right. So here this dt is the amount less than the margin. So it's easy to illustrate this in 2 dimensions. So maybe we've got a few points here, right? And so then this distance would be, epsilon 32, if this is 0.32, and that would be epsilon 43, if it's 0.43. Then we've got a point up there. So that distance would be epsilon 5, that's 0.5. And similarly for the blue points, it would be, there's some blue points here somewhere, and that would be epsilon, I don't know, 26, whatever. Right? So you get the idea. So for the most part, it's separable with this parameter gamma, but there's a few points where it isn't. And then we're going to get a bound on the number of mistakes that will be made in a single pass through the data. If it's separable, then after a while you stop making mistakes. If it's not separable, if you keep going through the data, then you're going to keep making mistakes, obviously. But in a single pass, we'll get a maximum of this many. And basically what you do is you add some extra dimensions. I'll just type this out. Add 1 extra dimension for each point, basically. Make each point k in its dimension. All the other points will be 0 in that dimension. So having a dimension that is only really occupied by each point, this means that everything is definitely separable, because you can, when you're doing the dot product, just take the corresponding parameter, and that's how you make it separable. Now, adding an amount k in an extra dimension, it increases the total distance r between points. Right, and so what we're going to do is we're going to take an m star, so a set of vectors that pretty much separates it, except there's going to be a few of these points that are within the margin, but within the margin in the multi-class case. And so for those few points, we're going to use their extra dimensions to make it separated with margin gamma again, except that then the norm isn't going to be 1 anymore, and so then we're going to have to, because the norm isn't 1, we're going to get another factor, and we're going to minimize with respect to k, and that's how we get this. So I would say you can consult paper by Shapir, something like that. By Shapir, or there's a 2002 paper by Michael Collins. That's actually how I learned it, but I might have learned it a bit backwards. I'm not sure if I spelled that right. All right.